Okay, we are going to start section 10.1 here today. And 10.1 is on circles. And 10.1 is mostly vocab. So there's quite a bit of vocab I want to show you guys here today. The first part with it is the definition of a circle. Now what a circle is, it's a set of points equidistant from another point. So if we call this middle point M, the circle will be the ring on the outside. It's a set of points equidistant to the same point or the center point called M. So it's nothing more than a set of points. Now when you have a circle, there are a couple things that are important. One, this distance here from the center of the circle to the circle itself is called the radius. The radius is nothing more than the distance from the center of the circle to the circle itself. Okay? So keep that in mind. A couple other things that we have in a circle is one called a chord. A chord of a circle merely connects 2 points on the circle. It's like points A and B. That would be a chord. Or I can do it in blue here. I could have something over here like chord X, Y. That would also be a chord. So a chord does nothing more than connect 2 points of a circle. Now if we extend a chord, you end up with what's called a secant. Secant line, I should say, because it is a line. Okay, and with the secant line, it's like a chord. It just merely takes a chord and extends it. So if you take these 2 points here and just go all the way across, this would be a secant line. It still connects 2 points of a circle. Call it, I don't know, P and D. But it's a secant line, whereas a chord is just a segment. It truncates. Now if we take a very long chord, for example, where would the longest chord in a circle be? It'd have to go through the center of the circle. That would be the diameter. The diameter is the longest chord of a circle. It is a chord that passes through the center. So it's a chord that passes through the center. And that would be a radius. That would be the radius times 2, not the radiator. The radius times 2, lengthwise, numerically, is the same thing as the diameter, because you got one radius over here, and you got another radius over there, so you get two of them put together, you end up with the diameter. Now, another thing we're going to come up with here with the circle is what's called a tangent line. If you take a point on a circle, and it only touches one line, we'll call this line L out here. L would be a tangent line. A tangent line only touches a circle in one point. So I could have one there. I'll do one here in red. We could have another one maybe down here where it touches in one spot. It should touch in one spot. Bad drawing on my part. Or maybe one over here where it touches in one spot. There are infinite many tangent lines. The cool thing with a tangent line is that it connects, and I'll do it in green here, from the center. The tangent line is always perpendicular to the radius at the point of tangency. So wherever the point of tangency is here, like on this one down there, it's always going to be perpendicular. So tangents are perpendicular to the radius. Tangents are always perpendicular to the radius at the point of tangency. So the neat thing about that is now that you guys learned some trig, We then can take a circle, have a tangent line down here, have the center perpendicular, and then all of a sudden you got a right triangle. So this piece was 3, radius is 3, and this was 4. We know that the hypotenuse here all the way across would be 5. Segment AB would be 5. What would this little piece out here be? Well, all radii are equal, so if this radius is 3, this radius here would be 3. The whole thing is 5, so this piece on the outside would have to be a 2. Then let's say we want to find angle B. You could take angle B and say, well, if I take the inverse sine, second sine feature on your calculator, opposite over hypotenuse, the 3/5, and put it in my calculator, I could actually find angle B, and likewise angle A, by using sine, cosine, or tangent as well. So the trig all comes back once again on these types of problems. Okay, now when you have a tangent, other thing with the tangent lines is this. If we have a point out here, call it P, and we make a tangent to P here and a tangent to P down there, these two pieces out here, these two tangents, are always going to be congruent. Think of it as like Earth, and you got a satellite out here at point P. These two things would both be the same. For example, this might be 8 miles, and this would be 8 miles. So I think of it like chopsticks picking up a grape or something. The two sticks are the same length. It's always going to touch at the point of tangency, here and here, and those distances would always be the same. Now from the center, remember, these would still be perpendicular, so you end up with right triangles there as well, which is always kind of neat. So you get some problems perhaps where you have a circle, tangent line over here, tangent line over there, and they tell you this is 36, and they'll say this is 3x. Well, then 3x would have to equal 36, where x is equal to 12. So you can solve for different parts of a tangent. So the two important things in this chapter, or this section rather, is that common tangents, this is called a common tangent, they're always equal. These two would be equal, and that tangents are always perpendicular to the radius. That's the most important thing in this section 10.1, because that gives you right triangles. Now, a couple other things, vocabulary-wise, in this section, is what's called concentric circles. If we have a circle there, a circle here, and a circle here, they all have the same center. So concentric circles all have the same exact center. Concentric. Con means with, centric means center, so with the same center. Those would be called concentric circles. Sorry about that, I closed the door. Lastly, with tangents. Tangents can be, you have two circles, say the big circle and a little circle. We can draw a lot of different tangent lines here. What I'm going to do is a different color. You can have a tangent here, a tangent on the bottom. Those are called exterior tangents. You could have a tangent that crosses in between, where it touches here and here. That's an internal tangent, and you could get one that's out this way. That's terrible drawing. You could touch here and here, which would also be an internal tangent. If circles are combined, like two circles like this butted up against each other, there'd only be one tangent line going right through here, that's internal, and you'd have one on the top and you'd have one on the bottom. So in that case, you'd have 3 common tangents to both circles. Up here, you had a combine of 4, 2 internal and 2 externals. Sometimes you get a situation like this with a circle inside of a circle. There'd only be one common tangent. So there's common tangents, internal and external. That's about it for section 10.1. I want you guys to go and do IXL U7 to a score of 90, and then I have some exercises for you in the book. Have a good day.